Good morning, folks. This is the second video of the services series. We take the plant we had set up in the services series video number 1 in steady state, and we upgrade it to simple dynamic simulation. Now, as far as where the videos are, just take a quick look on YouTube. There are a number of videos on the plant series. It says IViewOps Plant video 0, which is the introduction, and then plant video 1, there's plant video 2, 3, 4, and then there's the services series, which says IViewOps services video 1. So the services series number 1 set up the plant, and then the services video 2 will upgrade it for dynamic simulation. So let's go in here and take a quick look. What's exactly happening out here, and what do we need to do? Well, I did a few tweaks to the file between the first and the second recording. What I've done is I've gone in and put in the names of all the flow streams, and I've sequenced them. And I mentioned that to sequence them, you just click on it and you press the left mouse and you drag it one position up or down at a time to get it into the correct sequence. So I have all the names and I've color coded them. So you have the secondary effluent, secondary clarifier, underflow, RAS, WAS, all of them in sequence. Now, what's important for us to know as we begin dynamic simulation is that the user can control what output they want to see from dynamic simulation. For example, this flow stream, which is an anoxic 1 effluent, we have just selected steady state. So if you want dynamic simulation output, we need to click on that. And for now, for this video, as we are learning how to do it, we will click on each of the flow streams, which makes the output file larger, but it's still better to have the data in case we need to see if our results are what they should be. Okay, the secondary effluent was already selected, and we will select the primary effluent too. A few other tweaks that I did. I went into the primary clarifier and I introduced some internal mixing, which is the sludge blanket is mixing with the liquid on top and releasing some of the soluble products into the primary effluent. And I did the same for the secondary clarifier. I put in a little bit of internal mixing, in this case 200 meter cubed per day for the secondary clarifier, so some ammonia and orthophosphorus from the blanket will get released and out in the secondary effluent. So if you look at the steady state data of the secondary effluent, the ammonia here is 0.14 and the OP is 1.70. If you look out here, the ammonia is a little higher and the OP is also a little higher, largely because of the secondary effluent. So let's get to the meat of what we need to do. Let's look at the Excel file for a minute. I changed the starting date to a more recent date, Sunday, February 8th, 2015. We will import in these raw influent flows, which is essentially this pattern that you see over here. We will run it with just that raw influent flow pattern, but not do the DO first. Then we will go in and work through the DO pattern, and you can see that I will plug in a pattern of DO, which is essentially going to track my flow. So as if my DO and flow are kind of proportionate, and I'll explain why. Then the last part I will do is I will also have an air on-off cycle in the second anoxic zone, which I will do over here. And if you get some time, we will play around with the different wasting at different times of the day, but that does not have that much of an influence. So we'll start with a time dynamic flow pattern. Then we will add a time dynamic DO pattern. Then we will add a time dynamic anoxic 2 air on-off pattern. Let's go in here and figure out how to put in a pattern to the raw influent flow. So click on the raw influent flow, go to its controller. Now you see these three dots, and you should look up the user manual too. I think it's in user manual part 1B, the dynamic simulation. It's either in 1A or 1B, but I'm pretty sure it's in 1B. So click on this. It opens up this add child node, and click on the plus sign, and it asks you for a recorder or a scheduler. We will not go over a scheduler in this first dynamic simulation video. We may touch upon it in the more detailed one, which is the second dynamic simulation video, which will probably be video 4 in the services series. So let's click on the recorder, and here you see the recorder. By the way, you should look up the examples of the plant in the intro video, and if you have a license, you can look up the actual plants that have been set up, so you can get pretty familiar with how to do this. So we have asked that this flow controller have a flow recorder, which will have a record of flows over the last 24 hours or 72 hours or 1 week or 1 month, 1 year, whatever you want. Okay, now within the recorder we have to add another child asset, which is called the flow pattern. So click on this, the three dots again, and click on the green plus sign, and this will add a pattern. Now will come two important steps. The first step, go to the pattern and say, is it linked? And you have two options. You can either paste in the values right here, or you can use the is linked question and fill in this information. So let's go in here and set up a link. Now the flow, the cell with the flow over here, the raw influent flow, you have to enter the first cell in the series, which is cell E11. Okay, so we have done that. Now the second step you have to do is you have to assign the recorder to this time series. Otherwise what will happen is it will run without a recorder, which will be essentially the same flow all the time. So we assigned it to recorder 1. So now if I go review it, recorder 1 is assigned to pattern 1, and pattern 1, we haven't imported the data, so it's showing a same pattern. So now let's click on the import function and go through the import routine. So now we have clicked import, and it has imported the data, and let's look at this data, and you can see the flow pattern change at different times of the day. So we have brought in the flow pattern. So then we get into how do we initiate dynamic simulation with the right values. Let's go here to dynamic. Well, you can set the maximum number of time steps. Like for example, if I want to run a week, I set it to 672. In this case, I just want to run 1 day with 15-minute time steps, so I'll set this maximum time steps to 96. Now I could have changed it to 672, and then it would say it would set all the patterns to 672, and then I could solve only for 96. But here what I'm going to do is just stick to 96. Okay, it says it'll reset it to 96. Okay, now the time interval, 15 minutes is standard. You can in an SBR, in some instances we get it down to 5 minutes, but it takes obviously longer because there are more time steps to solve then. In some cases, if you're running an annual record, you may want to get it up to 2 hours or something like that. So you would then do 120 minutes. So here it's 15 minutes. The start time. Well, there are two ways you can set up your start time. You can either physically go in here and say, well, my start time is 28:15:00:00. So I'm going to go in here and set this to 2/08/2015 and set this time to 00:00. That's one way to do it. The other is you can link it to, is it linked to Excel? Okay, you click this and then go here, sheet 1, and enter the cell where this time is, which would be here. So this cell here is B11, and so I have B11. Now note that the format of that cell, the way it'll read it is it has a date and a time associated with it. We will get into this, what is the starting time step for dynamic simulation. Right now it's set to base scenarios, which is this scenario, steady state. It's going to start from the steady state number. Okay, so we got that far. Now the next step is to go into simulation. We've already run the steady state, but if you want to be sure, we can run it again. Okay, that's done. Now we switch it to dynamic. We've already imported the values and we will run it. So if I press run, it should start running the dynamic simulation. It'll go through all the time steps, which is the 96 time steps here, and depending on the capability of your computer, it may be much faster than what you're seeing over here. Also, I am on GoToMeeting, which slows the computations down. Now, it's important to check whether I have this dynamic simulation running correctly, whether I was able to import the data in. So let's go into the flow streams. Let's click on the raw influent, and herein I can already see a problem. It's not displaying the raw influent data because I have not selected the raw influent to display dynamic simulation data. But I did go in and do it for the primary effluent, and you can see the primary effluent has a flow record. I can go click on the secondary effluent, click on its ammonia. I can see that there is a bit of a trouble with the run in that it's essentially the feed data that the dynamic simulation is showing that the ammonia is going to creep up all through the day. And so the begin time step and the end time step are not the same. Okay, so now let's do two things based on this finding. One is, you can go to this flow stream, and if you want to see the raw influent data also in the results, you have to click on this. The next is, what do we want to begin as the first step of our dynamic simulation? Now that we have run it once, we can switch it to the begin is still the base scenario, but we will begin with the 96th time step. You can define the time step, but we'll begin with the last time step of the dynamic simulation so that the begin point is more accurate. Now, if you were running it inside a plant, when you set it up this way, it would be the 96th time step of the previous day. So essentially the dynamic simulation as it runs in auto mode every day inside the plant, it just keeps moving forward a day at a time. So let's rerun this and let's look at the results. And the results will not necessarily look good for ammonia. Our steady state on a 30-day average, or in this case a 15-day average, was saying 0.17. But our results from dynamic simulation, let's look at the flow weighted average, is going to be fairly high. It's going to be around 0.45. So let's look at the results again. Let's go to the flow stream. Let's go to the secondary effluent. Let's go to the ammonia. And so it's beginning here. If I run it one more time, the begin and end points will pretty much line up. But if you look at it, it's 0.42. I probably should run it one more time, and then this begin point will pretty much set itself to this. But this is a little on the high side. So what are my options? I can raise the MCRT by lowering the MLSS. That's one. If I do that, my MLSS, well, you cannot see the MLSS here unless you pull up the results. So that's one way to do it, but the other way is switch it back to steady state and you'll see the MLSS is already 3526. Well, do I want to run it higher? Well, one other option is to run, instead of 2 trains, all 3 trains online. Now, this plant, if you take a quick look, the liquid temperature we're running at is 20 Celsius, and the winter temperature at this plant, let's say, is 10 Celsius. So definitely we'll have some trouble in winter, which we will look in video number 3. We will evaluate whether we should run all 3 trains in winter. There are a couple of other alternatives. One is to play around with the DO. Or one other alternative, which is to play around with the DO. And the last alternative is to turn the air on and off over here. Let's look at the DO out of the aerobic zone. Okay, now one thing which I did not do here, when I click on this, I'm on steady state, so it'll give me a steady state number here. Now, what I need to do is switch it back to dynamic simulation, look at the results. Now, because of this, in a real plant, we set up the dynamic simulation in a parallel scenario, which draws upon the base scenario. So when you look at the KNSG plant or any of the other plants, you'll find that there is a CSS, which is current steady state, and a CDS, which is current dynamic state. So we separate the numbers into 2 scenarios. Well, right now over here, if you look at the secondary effluent DO, that's here. If I look at aerobic 1 effluent, its DO is set at a certain value. What if I increase the DO during the higher flow hours? Well, then what I can do is I can bring in a recorder. I can set up a recorder which will bring in the DO. So the DO set point controller is here under diffuse aeration. Go in here, and now we're going to add a recorder out here. So click on this 3 dots again, go here, say you want to add a recorder. Okay, so that's there. Then you have to add a pattern. So go here and say you want to add a pattern. Then go into the pattern and under select is linked. Say yes, I want to link it. Influent pattern, sheet, in this case, a sheet 1, toggle and figure out where the DO is. Well, this DO is on cell, it begins, the flow record begins on J11, and we just need to enter the first cell of the series J11. Okay. Now the second thing I mentioned we need to do is we need to assign the set point controller to the recorder, otherwise we will not. It will just say there is no recorder. So if it was stuck at none, we would have no variation in the DO. It would use the default value of 2.65. So we have set it to recorder 1. Next, we have to import the values because the software doesn't know the new set of values as yet. So we have imported the values. Okay. Now, in this instance, only this one is set to this recorder. What about this? Well, we have to go repeat the same set of steps and set up a recorder for the second aerobic zone by clicking on time series, going here, and going through the steps of setting up a recorder. So let me go ahead and set this up and come back. So what I've done now is I've set up the recorder for aerobic 2, the DO recorder for aerobic 2 and aerobic 3, and I need to import in the new sets of or the values for each of those recorders. And then if I go in and check, I will see that each recorder has this DO pattern for different times of the day. So there is one other place, one other auditing tool that I need to make you familiar with. If you click on this little arrow, down arrow over here, you will be able to see the controllers. You will be able to sort through which ones are attached to which file, which sheet, so you can check them here. You can also check the patterns. For example, the file name and which one, in this case the diffused aeration set point controller for aerobic 1 is attached to J11, aerobic 2 is also attached to J11, 3 is also attached to J11, while the raw influent flow controller is attached to E11. So this is a good auditing tool, and you can make changes also over here. If you think this cell is wrong, you can go edit it and make a change. You can change your sheet, etc. over here. So it's easier to sometimes to set it up over here. So now that we have done this and completed this, and if you go back to dynamic simulation, it's saying okay, is linked to B11. I have to check why. Last updated is this. Okay, that's fine. All this is fine. So I now need to rerun the dynamic simulation, and I'll press the run button. It'll go through the run, and I will come back to the recording once the run is done. So now we have finished the recording. It says it has run through all the time steps. It says end. Let's look at the results. Click on the results tab, or the results icon over there. Let's look at the flow stream. Let's go to the secondary effluent. Let's go to its ammonia. And we can also look at the data over here. This is the ammonia. It's still not very good. It's still on the high side for summer, but the DO is varying as expected. Okay, we could look at nitrates. It's on the low side. So what is the second option? The second option is to turn the third train on. Well, if my nitrate is still on the low side, I could cycle the air on and off in the aerobic zone. So in this case, I wanted to show you the example of how to set that up. So you go into anoxic, in the anoxic 2. And if you go into the anoxic 2, under aeration, say that, okay, there's a diffused aeration system here. Okay, now this diffused aeration system, let's say its normal set point is 2, but I'm going to run it with an on-off controller. So an on-off means the air will be on at certain times, off at certain times. So go in here, click on those 3 dots, and I'm going to add a recorder which says when the air is on and when the air is off. Okay, go click on pattern, go to the pattern, say is linked, yes, influent pattern, sheet 1, and this air on off is in cell K11. Okay, so now what we have to do is we have to import those values. Just because I set it up does not mean that the values are here. So now the values are here. If I check the pattern, it's there, air on, off, in 2-hour intervals, air is on and off. Now let me rerun this again, and I might see a problem. It says 1 error. It says steady state results not found, set initial guess. What I did was I suddenly added a recorder, which is a new asset. When you add a new asset which wasn't there before, because I'm just setting up the plant as a services, these things I might be adding new assets. Well, if I add a new asset, it asks me to rerun the steady state, so I'm going to do that. If you are already operating a model at a plant which has been set up, you won't have these issues because you're not going to be adding new assets. Oh, okay, I needed to run. Yeah, let me make sure. I need to rerun the steady state. So once this reruns, I think I have to save this. It's a good idea to save it periodically, but save it in a different name in case you need to go back to this file. So I'll click on the old file name and I will add D1 because I already have a file. I was testing what I was going to do. So I'm saving it as file D1. There you go. There's D1. Okay. So now I'm going to switch it back to dynamic simulation and I'm going to press the run button and I'm going to let it run. And this time it's running with the air on and off in the in the second anoxic cell, in addition to the DO set points changing in the three aerobic cells. So there's going to be more aerobic volume because in the second anoxic cell the air is going to cycle on and off, and the previous aerobic zone is still there and the DO goes up. We are running a slightly higher DO during the higher flow periods. So let it go through the run and then we will look at the results. Remember the last time the ammonia is to go up to 0.45. Now let's go to the results, look at the ammonia, and then we'll look at the nitrate. Go back to flow streams, go to secondary effluent, it's colored differently. Look at the ammonia, and look, the results are beginning to improve. Okay, now look at the nitrate. It's okay, it's around 5 milligrams per liter. Now, if I go back to this ammonia, it was starting at a different point. Let's see where we are starting our dynamic simulation and where we are ending it. Let's look here. Let's go to dynamic. It says base scenario dynamic 96 time steps. So let's rerun this once more so that it starts with the endpoint of the previous dynamic simulation run. So we've finished this run. Let's take a quick look at the results. Here we go, secondary effluent, ammonia. So now this is how it's behaving. At this time we had a lower DO and then we raised the DO here. So the ammonia is much better. If I look at the flow weighted average is 0.31, the nitrate is 4.6. Here's the nitrate graph. So we achieved that objective that we had of trying to lower the DO. Now you won't be able to see the mixed liquor here, but you could go to the results and see it, or you could switch back to steady state. If I click on the line, if I go back to steady state, it'll give me the steady state mixed liquor of 3300. If I wanted to see the mixed liquor here, I would have to go back to results, which we will do. But before we go there, the one last controller we said we would try is this WAS flow controller, where we want to now add essentially add a WAS flow recorder. So go back here, add a recorder, go to the pattern, add a pattern, and then press the select. Here is linked inflow pattern sheet 1 again, and the WAS pattern is on G11. Okay, and do not forget, which is easy to forget, we'll have to make an update to the releases so that people do not forget. We have to set this WAS flow controller to the recorder over here. Now, next thing is to import the data. And now we have a lot more controllers. If you go into the auditing tool, if you go into patterns, you'll see that now we also have the WAS flow pattern here with G11 stated here. Okay, so we will rerun this again, and we will review the results once more and then save the file. and get back to dynamic simulation in file number 4, where we may look at multiple scenarios, including solids dewatering, which may operate at different times of the day. So just to summarize, video 1 in the services series went through steady state simulation. Video 2 picks up on dynamic simulation. Again, video 2 in the services series. Video 3 in the services series will show you some solids handling and may refer you to some of the real plants which have different types of solids handling. And video 4 will start looking at dynamic simulation between different scenarios. Okay. We also looked at making sure that you save the results here, and for that you have to go into each of the flow streams and click on the button or check the button which says are you going to save the results or not for the flow stream. If I go to, let's say, aerobic 3 over here, and if I look at the TSS, this is my TSS at different times of the day based on wasting and other things happening here. Okay, this is my ammonia, this is my nitrate in, let's say, the aerobic 3. Now, if you would like to set up a dashboard, you click on the dashboard and you can go to flow streams, and we cover this in video number 2 of the Plant series, how to set up your dashboard. You click on this and then you right click, say add panel, and a panel gets added which will have your flow, ammonia, etc. over here. So I will not go through the dashboard. I will just refer you to video number 2 of the Plant series, and you'll be able to see how a dashboard is set up by the plant operator or the engineer and used on a daily basis, or just used as a place to view several results. Okay, adios. We will see you in video number 3.